Hello everyone, this is Daniel from Land Software, and in the following video we will create a simple landscaping project where the goal is to design different landscaping elements and create a new terrain, while using as a reference the existing terrain from the project site and the existing road neighboring the project area. A short introduction into the file structure, Land4 categories and settings before starting the job. First, unzip your exercise files. You'll see 3 folders containing all necessary files. In the first folder, we'll find the projects in a start phase and also in the done phase. Then we have a folder for the data import with the existing road in a LandXML format, and we have the existing terrain as a CSV file representing the spot levels. The last folder we can use for exporting the final project in different formats. We can start by opening the project in ArchiCAD. Select the project Landscaping Start and open it. Now that the project is open, we can go through a few settings of the project. So we start with the layers under Land4 folder. We have all the layers already placed. If we go to the category settings, we can also see the categories that are prepared in the project and each layer assigned to the category. The last thing we can check before starting the project are the composites. In the Land4 folder, we also have the composites prepared for the landscaping elements we are going to build. Also, the composites can be found on the land surface settings and land surface composite. When you activate the button, you'll be able to see the composites in the land surface composite box. Here is where you can apply the composite to your surface. Under the model view options and options for Land4, we also have the categories with the settings applied. Finally, you will also find embedded in the project a building, which will be used as a reference when constructing the terrace. Imports: the XYZ file representing the existing terrain and the LandXML file containing the existing road neighboring the project area. First, let's import the file representing the existing terrain. Go to Import from XYZ file, find the file. If you want to check it, you can also open it in Notepad, where you can see in the first column, you can see the ID of each point, the tabulator represented by the semicolon, and then we have the X, Y, and the Z coordinate of each point. Therefore, in the tabulator, we'll select the semicolon, the ID is in the first column, the category is in Land4 existing, the unit is in meters, as represented by the coordinates, and we will import it by the project origin. Now the spot levels are imported in the project. Next step is to import the LandXML file. So go to Import from LandXML file, select the file. We're going to import it by project origin, as it's in real world coordinates, and press open. The import is now successful, and we can see already a road. In the 3D, we can now set a composite, so you can select each of the surface, press on Land Surface Settings, go to 3D Structure, select Composite, and under the Land Surface Composite, activate the button and select the right composite called Road. The composite is now applied to the land surface. When you import a file from a LandXML in Land4, they will be imported in the uncategorized category by default. Also the spot levels and all the elements in the file. Therefore, if we want to change it to road, we can first use the selection palette and select everything in uncategorized, all Land4 elements, close the palette, and move it into the road category. Now if I select the model, we can see it's in the road category and in the road layer assigned to the road category. If we check the spot levels closer, we can see now they have a different color based on the category. But we can also make a new selection for the spot levels within road category. And using the spot level settings, we can change their appearance. So I uncheck the model view option and I will just change the text size of the spot levels in road category. This way will be easier to differentiate it in the plan view. Creating the existing terrain. Using the imported spot levels, we will create the existing terrain. But first, I want to enlarge the text of the spot levels under the general settings of the spot levels. So I'll increase the spot level text size. So now we are ready to create the first surface. Set the active category to land for existing. Press on the function button. And now we're going to use the outer boundary of the project area. The spot levels are automatically selected based on the category, and then we just need to confirm the operation and input a name for the existing terrain. Once we have our surface, we can now access the land surface settings and set the level lines for the land surface in both 3D and 2D with a height distance of 500 millimeters. If I press OK, now the level lines are set to the surface. The model can now be visualized in the 3D altogether with the level lines. By using both the 3D model and the level lines, we can observe the natural flow of the terrain over the landscaping areas we are planning to build. This can be useful in taking decisions of the fall directions or the fall percentages. Designing the new landscaping elements. The first element we're going to build is the parking area. We have the polyline already in the project, and we can see the natural flow of the terrain based on the level lines. I can now hide the existing terrain, and before I start constructing the parking, I make sure the active category is set to parking. Now I'm going to use the existing and neighboring road to place a spot level using the Land for Gravity tool where the polyline meets the road. I'll use both ends in order to make sure that my parking will meet the road, precisely in that point. Now using the first point, I can use the constant gradient interpolation. I'll use a fall of 0.5% towards this corner, which matches also the natural flow of the terrain. I place now each point in each corner and hit escape when you're done. In the 3D, I can't see the ridgeline yet because it's not created, but I can already select and show the spot levels in the parking category, which are going to be used in creating the line. So now I can just select all the spot levels together with the polyline. Then I can press on Create Ridgeline function. The ridgeline is now created. Using the Create Line Surface function and the magic wand, I can create the first surface and call it parking. Back to 3D, we can now visualize the surface, select it, go to Land Surface Settings, 3D Structure, select the composites, and under the Land Surface Composite, define which composite to be applied to your surface. I can also place some level lines over, both in 2D and 3D, using the same height distance. We are now ready with the land surface representing the parking. In the following part, we will construct the sidewalk neighboring the parking. So we do have the polyline in the project already, which we're going to use to construct the first ridge line. First, make sure you set the sidewalk category, and then select the first spot level with a gradient interpolation of 2% fall, and place the first spot level for the sidewalk. Continue by interpolating the next points, in each corner defining the sidewalk. For a better overview, I'll move the text for some of the spot levels representing the sidewalk. And now I'm ready to create the ridge line. So this ridge line will contain both spot levels from the parking and from the sidewalk, as you can see. Now I press on the create ridgeline function, and the ridgeline is already created. So the ridgeline defining the sidewalk is in the sidewalk category and layer, while it contains also points from the parking. Let's continue by creating the land surface and using the magic wand and inputting a name for the sidewalk. Next step is to select it, press on land surface settings, 3D structure, and apply the composite called sidewalk. We are now done constructing the second landscaping element. The next element we're going to build is the terrace around the building. So I start by setting the terrace category active. And here we're going to start by placing a few spot levels in the 3D. I can hide the existing terrain for now and navigate in the 3D to the corner of the building. Here, using the gravity, I will set the first spot level, and I'll place one in this corner as well. Back to 2D, I can see now the spot levels on the plan view. I will set the rest of the spot levels in the plan view once I have the right elevation, which was easier to obtain in the 3D. I will set a spot level for each corner of the building because I'm planning to construct the terrace with different falls for each corner. Let's continue interpolating new spot levels and defining the edge of the terrace. We start with the first point, a gradient interpolation, and I start with a 0.5% fall. Using this new point, I will interpolate the next one using, once again, a gradient interpolation and a fall of 0.2% this time. As for the next spot level, I will use a 2% fall, since I'm aware that the existing terrain is much lower within that location. Same with the following spot levels. Of course, you can always edit or update your spot levels together with a surface in order to match the volumes better. You can always check the relation of the interpolated points by showing the dependencies. We can now place some fall lines. Before that, we can check the default settings, which follow the model view options. And we can also open the model view options and see the settings in the fall line. Now we can place the fall lines in between the spot levels that we want to see the fall. The role of the fall lines in the project is to document the falls in between two spot levels, but also to help us taking a decision when designing a surface. Now that we have all the spot levels in place, we can start creating the ridge lines, which we will use to create the surface. So we use the selection palette, where we want to make a selection in the terrace category and the spot levels. Together with the selection, we will have the polylines and we'll press on the function button. Now the lines are visible in the 3D. And the first line will help us define where the terrace will meet the building, while the outer boundary will define the terrace edge. Now we use the magic wand and simply create a surface and input a name. The land surface is now created. Next step is to create a hole for the building print. Select the fill, press on the fill tool, and using the magic wand and the polyline, cut the hole in the surface. Select the surface and go to the land surface settings, 3D structure, and place the composite called terrace. The surface altogether with the composite is now visible in the 3D view. The next step is to place level lines over the surface under the land surface settings and level lines. In this case, we will use a smaller height distance, 20 millimeters, which will help us understand better the surface falls. In the next part, we will use the elevation palette to modify the fall in between the spot levels. So if you activate the elevation palette and select 2 spot levels, the elevation palette will pop out. And here we have 3 parameters: the top, the bottom spot level, and the fall in between. First, we need to lock one of the parameters, in this case, the spot level around the building. And then we can change the fall in between the spot levels. I will change it to 2. I get a message that I need to break the dependencies. And now the spot level at the corner of the terrace has been edited, along with the surface. You can also activate the elevation palette by selecting the fall line. And once again, if I lock the parameter by the building, I will try another fall. While I do that, we can see that the other fall lines showing the fall in between the other corners of the terrace are modified. I will continue by changing the fall also on this corner, breaking the dependencies, and updating the surface. I'll place another fall line in between the spot levels, defining these corners, and now I can see I have a 0% fall. Therefore, I can modify again the surface by editing the spot levels, keeping in mind that I want to have a fall in between the spot levels of minimum 0.1%. The next element we're going to construct is the walkway. Here we already have all 4 spot levels from 2 different categories. However, the ridge line we're going to construct is going to be placed in the walkway category. First, we'll make the walkway category active to make sure our ridge line will be placed in that category. Then we select all 4 spot levels and press on the function button. The ridge line is now created. And if we select the ridge line, we can see that it's in the walkway category and layer, while the spot levels are placed in the category they were before. The next step is to create the surface, and we can see in the selection only the ridge line is selected. We'll input the name, and the surface is created. In the land surface settings, once again, under 3D structure, we'll add the composite called walkway. Here is the land surface altogether with the composite. The last landscaping element we are going to construct is the playground. I'll start by placing the playground category active. I will also show the existing terrain because I would like to ensure that I have a starting point based on the existing terrain. So using the gravity tool, I'll place a point in the corner using the existing terrain as a reference, and also counting on the natural flow of the terrain, I can see that I will have to use a fall on this direction. I can hide now the existing terrain and select the point, use a constant gradient interpolation, where I'll use a fall of 2% and set the direction fall. Place the rest of the spot level in each corner represented by the playground area. Select all the elements and create a ridge line. Now you can create a land surface for the playground. Input the name, and the land surface is created. Now you're ready to select the surface. Go to Land Surface Settings, 3D Structure. For the playground, we will use land surface with thickness. Search for the surface material called Playground Rubber Red, and also for the building material. The land surface thickness should be set to 200 millimeters. Creating the new terrain. Now that we are done constructing the landscaping elements, we are ready to create the new terrain. So first we will show once more the existing. And the next step is to use the spot levels from the existing. So we will use the selection palette to select the spot levels within Land for Existing category. Now we will use Copy to Category function to copy to Land for New category. If we zoom in, we can see that the spot levels from new are overlapped now. So we can select and hide the existing spot levels together with the surface. And what's left is a copy of all the spot levels used for the existing terrain. The next step is to start deleting the spot levels that are overlapping with our newly constructed landscaping elements. Before doing that, I will change the size of the spot levels within Land for New. So I make a general selection and access the spot level settings. Now we have 131 selected elements. I uncheck the model view option and change the marker size to 1 and also the text size to 2.5. This will just make it easier to visualize the plan view and emphasize the spot levels of the constructed elements. Now I just need to select all the spot levels overlapping with the newly constructed elements. You can of course also use the Find and Select tool altogether with a Marquee tool in ArchiCAD. I just prefer to do it manually because I have more control over the selected spot levels. Now we can delete the selected spot levels. Before creating the new terrain, I set the Land for New category active and use the magic wand. Now we can see the selected elements are the ones part of the Land for New, but before I will also add to the selection the ridge lines of the newly constructed landscaping elements. These ridge lines will be used in defining the new terrain and where the new terrain meets the elements constructed. The ridge lines are now added to the selection, and now I can confirm the land surface creation. Input the new terrain name and press OK. We can now add the level lines under the land surface settings and show them in both 2D and 3D using the same height distance. In the 3D view, we can now see how the ridge lines are defining the new terrain. To understand better the differences in between the new and existing terrain, show the existing terrain from the layers. Select the existing terrain and under the land surface settings, 3D structure, change to another surface material. Just by looking at the 3D model, we can already see where the fill will occur, but also where the cut would occur in between the existing and the new terrain. Now that we have both new and existing terrain, we can continue with the next phase of the project. Land4 volumetrics. Set the active category to volumetrics, then press on the function button. Here we have the first surface as existing terrain and the second surface called new terrain. Press continue, and using the magic wand, use the same border or the outer boundary of the project area. Place the stamp in the last step. The volumetric stamp will show the volume involved in the process. Back to the 3D view, we have also the volumetric surface as a result. Here we can see the fill and the cut in 3D, but also the area that's neutral. Using the gravity tool, we can also read values along the surface, where we can see where it's cut or fill and how much along the surface. Let's go back to 2D. Let's try to remove more spot levels around the constructed elements. And I will make a selection of the spot levels closest to the playground. If I delete them, the Land4 new surface will update. And then I can go to the volumetric stamp, select it, and press on refresh volumetrics. At the same time, the volumetric surface will update in the 3D with the new results. The Land4 drape function. In the next part of the video, we will create a hedge around the south and east part of the project, where we have basically two polylines where the bottom will be draped to the surface, while the top will be draped with an offset. In this way, we can ensure that the ridge lines created will be following the terrain all around. First, let's set the active category to planting. And then we can drape the first line. So we select the first line and the land surface, the new land surface, and press on the drape function. We have now obtained the ridge line that will represent the bottom of the hedge, and that will assure us that the hedge will meet the land surface. The next is to create the ridge line, which will be used to create the top of the hedge. Drape with offset function will be used, and I'll use an offset of 1500 millimeters. Now both lines are visible in the 3D. In this way, using a drape with offset, we make sure that the lines are parallel on a Z direction and they follow the terrain. Using the selection palette, we can now check them and select them on the surface. Now that they are selected, we can create a hedge using just these two ridge lines, using the magic wand on the outer boundary and inputting the name. Now you can change the fill type and the fill pen. The surface is now visible in the 3D. You can select it, land surface settings, 3D structure, and now you can change also the surface material. Now that we are done creating the hedge around the project area, we can also place different ArchiCAD objects over the surface. Let's start placing some trees around the hedge. By default, when you place ArchiCAD elements or objects around the area, they will be placed to the height inputted in the default, in this case to 0 level. But now we can drape them by selecting all the trees and the land surface and press on drape function. Now the trees will be draped to the surface to their exact location, but following the Z value or the height according to the land surface. Once your ArchiCAD objects are draped to the surface, you can still apply or change different settings of those objects. So if I increase the height of the trees, for instance, those settings will be applied to the elements while they will still be draped to the surface. Also, if you modify the land surface, the draped objects will follow. Reviewing composites and schedules apply to land surfaces. First, let's create a new schedule for the land surface. Under Schedules and Scheme Settings, you can create a new schedule where you can input an ID and a name for the schedule. Place it on the components and say OK. Delete the default criteria and search for land and add the land surface. Place the check mark as true to the land surface, and now we can continue by adding fields related to the land surface. Once again, we can use the search word land, where we can see all the land4 parameters that we can add to the schedule. In this case, I will use the analytic surface, horizontal projected area, surface thickness, and the name of the land surface. And place the name of the land surface the first in the schedule. Now under components, we can also add different volume parameters that will be showing the volumes of the building material that we have used in the composites over the land surface. I will also add some information about the building material, such as name, and rearrange the order of the parameters in the way I want to be shown in the schedule. You can now open the schedules and visualize the results. The schedules are now showing the parameters set in the scheme settings, based on their name for each surface, altogether with the areas and the volumes. Land4 exports. First, let's start with the IFC export. So while you are in the 3D, you can just go to File, Save As, and make sure you have the type set as IFC. Then you can just input a name. The IFC export warning, it's related to the spot levels in your project. That happens because they have no volume and the IFC format is based on that. Using the IFC viewer, we can simply load the file and visualize it. In the IFC viewer, we can see now that in the new terrain, it's overlapping with the landscaping constructed elements. Depending on your project purpose, you can always create holes in a surface. So using the fill tool, I can just create holes in the new terrain, overlapping the constructed elements. We initially used the whole surface for the new terrain for the volumetrics purpose. Save a new IFC file where this time your new terrain contains the hole overlapping with the landscaping constructed elements. In the IFC viewer, we can now see the difference. The LandXML export can be done both in the 2D or 3D view, where the layers shown or the elements stored in the visible layers will be exported. Go to Export to LandXML file, set the project origin as the export reference, and input a name. Using a third-party software to visualize the LandXML, we can now see the model all together with the spot levels. Let's also make an export for the spot levels in the project. First, I will select the spot levels for one category, for instance, parking. So now I have the spot levels selected. I can access the spot level settings, the selection settings, and add some text for the prefix or the suffix of the point. For instance, parking. The spot levels used to create the parking have now a text defining their functionality. Now go to Export to CSV file, export by project origin, since we use the same export reference for all exported files in the project. We can now check the file structure by opening it into Notepad, for instance, where we can see the point ID all together with the coordinates of the points, but also we will see the text we added to the spot levels defining the parking area. Same as in the previous exports, Land4 will only export the spot levels that are shown in the project. Thank you for watching. This is Daniel from Land Software, and until next time, for more videos and tutorials, visit our YouTube channel or land4cad.com.